Hello, welcome to CM Square Learning Center. In this chemistry lesson, I'm going to talk about these two IBMYP questions from past paper. This is topic 5, energetic SL part, and these two questions is to test students whether they understand the definition of a standard enthalpy change of formation and combustions. The first one is about formations. Which reaction has an enthalpy change equal to the standard enthalpy change of formation? At this temperature and pressure. It's a standard temperature and pressure conditions. So students should know the definition of a standard enthalpy change of formation. The definition is the enthalpy change when 1 mole of compound is formed from its constituent element under standard temperature and pressures. Yeah, so the key thing is when 1 mole of compound is formed from its constituent element under standard temperature and pressures. So the first part, 1 mole of compound. Let's look at all the choices. So answer D, we have to eliminate the answer D because there are 2 mole of compounds formed. And also compound B is also eliminated because the product is not only the alcohol but also the oxygen. So we have to eliminate answer B. For A and C, let's look at the difference. So for C, C4H8 gaseous compound plus the water in gaseous state to form a 4-carbon alcohol. Yeah. While in option C, it's a carbon, hydrogen gas, and oxygen gas. So actually, answer C is correct. Because for the compound C4H9OH, there are 3 elements, carbon, hydrogen, and oxygen. So carbon as standard condition is a solid. For hydrogen is a hydrogen gas, H2 gaseous state, and oxygen as well is an O2 gas. Question 2. Which reaction has an enthalpy change equal to the standard enthalpy change of combustions? The definition for an enthalpy change of combustion is when 1 mole of compound undergo a complete combustions, under standard temperature and pressures. So complete combustion means react with excess oxygen to form a CO2 and H2O, excess oxygen, forming CO2 and H2O. And under STP, standard temperature and pressure. So let's look at A and D. So these two compounds, the water is in gaseous state, while B, C, the water is in liquid state. But at standard temperature and pressure at this condition, water is a liquid, so we have to eliminate A and D. Also, C is also eliminated because the definition when 1 mole of compound is burned. But now there are 2 mole of compound in option C. So that's why the answer is B.